Hello, welcome to Zigmatech Learning Hub. I will be your instructor for physics. For this class, we are going to be taking our exercises from Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell and get updated on new videos. Are you ready for this class? Okay, let's get started. Welcome to physics class, and today we are going to learn motion under gravity. By the end of this lesson, you should be able to define acceleration due to gravity and write the equations of motion and give reasons for variation of g at different places of the earth, and also do a few more calculations relating to motion under gravity. Are you ready? Let's get started. So if you look at the video clip you're watching on your screen, I want you to really understand what motion under gravity is all about. A free fall, many people always call it a free fall. Motion under gravity, that deals with the body. When you throw a body, the body falls onto the center of the earth and all that's associated with it. So they say that there is a gravitational pull of the earth on any unit body or mass. So now, looking at what you are seeing on the screen, you realize something. As the body is going, or as the body is thrown up, a gravitational force or gravitational field is acting on it. Whether it is going up or it is falling down, gravitational force or pull is acting on it, provided that it is a body of mass, of course. Now, but then what happens is this: when it is thrown up, the velocity will keep on increasing until it gets to the highest point. Then it starts falling, and when it is falling, what happens to velocity? Velocity will be increasing at every stage as it is falling. But what you notice about the acceleration, that acceleration is not just this acceleration. It's not this. It is g, which is called acceleration due to gravity. So it's acceleration due to gravity, and it is constant whether the body is going up or falling down at any stage on the motion of the body. That is exactly what motion or motion under gravity is talking about. However, a few more information will be given to equip you on what this is all about. And that starts with the first one. Acceleration due to gravity is defined as the force of attraction or a pull of the force of the earth on a unit mass. So from that, we now have that we say F is equal to mg, or sometimes we say that weight is equal to mg. Any of them, both this and this, they are the same thing, because there is a kind of special force which is called weight, because it is acted upon by a gravitational force. Then we say that acceleration due to gravity is equal to the force per unit mass, and that is what acceleration due to gravity is. The best definition at your level for now. Now, when we are talking about the equations of motion under gravity, it's not like the one you've learned on the rectilinear motion or motion on a straight line. This one is different because of the orientation or the kind of motion that is being occurred. Now, let me remind you of the equations of motion you've learned. When we also did the derivative of those equations, we said that V is equal to U plus AT. We also say that, I love to bring this in, really do, U plus V divided by 2, that is average distance is average speed multiplied by time. And then we also have this one, which is V square is equal to U square plus 2AS. And we have the other one, which is called S is equal to UT plus half AT square. These are the formula for motion, especially when a body is moving on a straight line motion. But when we talk about motion under gravity, all these parameters change Therefore, V is equal to U plus or minus GT. I want you to be very careful with this, plus or minus. Acceleration is no longer the rectilinear acceleration or uniform acceleration. You are now dealing with acceleration due to gravity, which is also uniform. Then I will leave this. Then I will get to this point where we say that V square is equal to U square plus or minus 2GH, right? At this point, we are saying that the acceleration here changes to acceleration due to gravity. The linear distance changes to become height because the body is acting up or down. Then the last one, which is S, is also H, which is given as U. Okay, I don't want to, let's leave it. This is general formula, plus or minus half GT square. Now, what is the sense of this plus or minus, which I have put here? This plus or minus is dependent on the direction of the motion of the body. If the motion is thrown up, remember, acceleration due to gravity is moving in this direction. So for a body to be falling down, from a height, the acceleration due to gravity is going to be positive. But if a body is thrown vertically upward, going up, acceleration due to gravity is going to be negative. So that is the essence of the plus or minus. So it depends on the question that you are given. This is just a general formula. The question you are given will require you to model it to what you want to get. And also remember that the time taken to reach the maximum height is half of the total time taken for the body to spend on air. That is if you go to take it from the angle of a projectile, because it's the same thing as projectile motion. However, the projectile motion, the only difference is the angle being considered on the process. Also, there is something we say that U is 0. Whenever we say that the body is at rest, U is 0. Or we say that the body is falling down from a height, U is 0. Or we say that the body at maximum height. Let me throw more light with a diagram for further illustration. If a body is thrown this way, the body makes this. Now, let's assume that this is the horizontal ground. Then this is the final height where it got to before it starts falling down. That is the maximum height. And at the maximum height, we say that the final velocity at that maximum height, at that point in time, is 0. Yes. And the time takes to go from A, let me call this place point A, let me call this place point B, and this is point C. These are 3 stages of this motion. The body moves from point A, down to point B. If the time here is 3 seconds, then the also time from here until it gets to this place is another 3 seconds. So what am I saying? The time taken to reach the maximum height is half of the time it takes to go from here down to this place. So they are the same thing. Also, I want you to know that when a body is falling from a height, if this is a height and the body is falling down to hit the ground, then at this point, at this particular point, U, the body initial velocity is said to be 0. But before it hits the ground, before it just hits the ground, V is the maximum at that point. And that is why we give it as final velocity. So anytime you are talking about motion under gravity, you are talking about 2 stages, 2 major stages from point A to point B. If you can fully understand that, even at this point now, U is 0. And each of these stages of this motion, U is always 0. So these are the paramount stages. Rest, final. Then rest, final. So if the starting point is 0, then the final state may also be 0, depending on analysis. But a few questions we are going to solve will further give you the required analysis for this lesson. Now, let's talk about variation of G at different places on Earth. So the acceleration due to gravity is not the same in all the places. However, remember that we said acceleration due to gravity, look at it here, is 10. 10 meters per second square, it doesn't change. That is the constant acceleration for a body undergoing motion under gravity. However, it is not going to be 10 in all places, but some other exam bodies prefer to use 9.8 meters per second. But probably some other exam bodies prefer to use 10. Which of them? They are all the same value. But however, in all the places of the Earth, acceleration due to gravity is not the same. Now we are going to look at some of those conditions that differ the value of acceleration due to gravity from place to place on the Earth. Number one is the distance of objects on the Earth's surface to the center of the Earth. That is, the distance of the object on the Earth's surface to the center of the Earth is not the same. So variation of that distance changes that acceleration, especially when you want to consider in terms of the force. So because of the distance of the Earth is not the same, and that is also based on the shape of the Earth, so acceleration is not going to be the same. Number two is shape of the Earth, which I just mentioned. It's not perfectly sphere, but elliptical. So, and because of that, it does not have a perfect radius. Look at what I mean by elliptical. Elliptical came from a circle. A circle. When you talk about a circle, you are talking about a perfect, a concentric body. Like a body in this. This is not even a perfect square, but something close to this is a circle. But the Earth is not this way. The Earth is flattened. So because of this is called elliptical. Just like according to Kepler's law, you know, when we talk about the ellipses. So we talk about as if that this particular center is now having to a little elongated. In that case, because of that, where are you going to consider to be the radius? The radius is no longer going to be the same throughout. And that is also one of the reasons why the acceleration due to gravity is not going to be the same in all. Another one is the Earth's density. The density of the Earth also has a part to play. And then the rotation of the Earth is not uniform. It's not uniform in the sense that Kepler's law talks so much about this, such that at the second foci, the movement of the Earth at that one is a little faster than the other one, even though they sweep the same area. Then also, another one is the magnitude of the force of attraction varies, because the magnitude of the force of attraction varies according to gravitational Newton's law of universal gravitation. Is also one of the conditions why G is not going to be the same at different places of the Earth's surface. Now, let's talk about a few questions on the equations of motion under gravity. A ball is projected horizontally from the top of a hill with a velocity 20 meters per second. If it reaches the ground 4 seconds later, what is the height of the hill? Okay, this is the hill, and the body was thrown this way. This is the ground. So velocity, if you consider the velocity at this point on the ground, then there is no need for velocity because it's 0. However, the velocity I'm talking about is just before it hits the ground. The velocity just before it hit the ground is that the velocity I'm talking about. So I'm going to call this place stage B, and I'm calling this place stage A. So at stage A, U is 0. But then, U is 0 at that point. Then when it starts going, it has a given velocity with which it started moving. But then, that velocity is given as 20 meters per second. That is the velocity at which it started moving until it hit the ground. Now, if it reaches the ground 4 seconds later, so the time from here all the way to this place is 4 seconds. Then what is the height of the hill? So this height is what I'm looking for. All right, I think the best formula is this. The reason why I'm using plus is that the body is falling down. It's going in the positive G direction because G is acting downward and the body is also moving in that direction, so I'm using positive. So the height is going to be, u is 0 at the first stage, so everything here is going to be 0, plus 1 over 2 times, acceleration due to gravity is given as 10, times t squared. T is 4, and 4 is 4 squared. So this into this is going to be 5. H is going to be 0 plus this is going to be 5 times 16, and which is 80 meters. So the height of the cliff or the hill is 80 meters, according to this question. Now, a stone is released from another example. A stone is released from a height of 80 meters above the ground. Calculate its velocity just before it hits the ground. Okay? This is the same thing, but at this point we know the height is 80 meters, and then a few things changed. I don't know the speed. I don't know the speed with which it hit the ground. Okay, I'm going to consider a few things. Remember, u is 0 here, and I don't know this one. I'm going to use this formula. This is the best formula for this question, plus 2gh, all right? U is 0. V square is equal to 2 times 10 times 80. V square is going to be equal to 1600. So V is going to be square root of both sides, and V is going to be 40 meters per second. That is what V is going to be. Anytime they tell you that the body is falling from a height, and then you are looking for velocity, this is the perfect formula for it. The velocity with which the body hits the ground. Another example, he said a body falls freely under gravity. Okay, these all the questions are coming. A body falls freely under gravity of 9.8 meters per second from a height of 40 meters. Okay, this body is that is the same question. When we're now using our Examguide app, we have more other questions differently. All right, the height is 40. Okay, no, this one is a little different. A body falls freely under gravity from a height of 40 meters onto the top of a platform above the ground. Its velocity on reaching the platform is okay. So the body is falling down, but they didn't reach the ground because there is a little platform above the ground. This is the ground level, and this platform is 0.8. So we are talking about the velocity on reaching this platform. So V at this point, before it hit that point. So U is 0 at this point. And the height above the ground is 40 meters. In this case, I'm only checking from here. That is what I need. From here to the top is what I need because of 0.8 meters is out. Therefore, 40.0 minus 0.8, this is 2, this is 40, this is going to be 39.2 meters. So I'm going to use 39.2 meters as the height. All right, and remember what I said previously, that this kind of question you need this formula, u square plus 2gh. So the height is no longer 40, it's going to be 39.2. So I'm having v square is equal to 0 plus 2 times 9.8 times 39.2. Two times 9.8 times 39.2. So we have v square is equal to 768.32. So square root of 768.32, then v is going to be equal to 0.8 is going to be equal to 27.7 meters per second. All right? That is what we have on this place now. All right, we have one more question. We said that an object R leaves a platform XY with a horizontal velocity of 7 meters per second and lands at Q. Takes the same object 0.3 seconds to fall freely from Y to P. Calculate the distance. Okay, we are looking for the distance from this point to the point here. If you have checked our video on projector, you know that that is called the range. So, and I know that U at this point is going to be 0. And the speed with which the body left is 7 meters per second. And the time from here before it hits the ground is 0.3 seconds. Then the distance. What I need to be able to get this is that, remember that V, speed, is equal to distance over time. Because distance here is the range. So we said that the range is equal to V times time. So, and the V is already given as 7. So I'm going to say that this is going to be 7 times 3, 0.3. And that is going to give us 2.1 meters. So the distance from here to here is 2.1 meters. Thank you for being part of this class. And we have come to the end of it. However, before we go, we are going to take a few more exercises from Examguide app. Okay, we are on Examguide app now. I'm using UTME JAMB. So we are going to take a few more questions on this Examguide app. Let's get started. So the question here is saying a stone and a feeder. Very important. I love this question. It said a stone and a feeder drop from the same height. So this is a stone. Let's assume this is a stone and this is a feeder, right? And are dropped from the same height above the ground, above the surface of the Earth's surface. Ignoring the air resistance, which of the following is correct? Okay, the feeder will be blown away by the wind while the stone will drop safely. All right, but remember the question says ignoring air resistance. So at this point, we are taking air away from the equation or from the happening. Number 2, so the option A is not correct. B says the stone will rest on the ground first. Why will that happen? That was the mistake Aristotle made by saying that a heavy body will first fall on the ground while the lighter body will fall later. That was a misconception about acceleration due to gravity, which is the essence of our topic. That is also wrong. C, the stone and feeder will both reach the ground at the same time. The feeder will reach the ground first, all right? C is the right option. Why? But in a real life, that is why you can't come to learning physics with your normal physical eyes. You need to look at physics from the experimental aspect of it. Because it is stated clearly that the only reason why let me say, both the feeder and the stone, they are all acted upon by the same force of gravity. So why will the stone fall first before the feeder? Just because of the resistance of the air. Air resistance is affecting the feeder from falling down. But when you ignore air resistance, as the question stated, the option C becomes the best because both the feeder and the stone will hit the ground at the same time. And option C is correct. He said a body starts moving with a velocity of this accelerate. I'm considering the one under motion. A man standing on a lift, okay? A man standing on a lift that is descending, the lift is descending, does not feel any weight because a man standing on a lift and it is falling down does not feel any weight. Why? Option A, the lift is in a vacuum. No. Have you ever seen a lift in a vacuum? In a vacuum means that there is no air, so a human being cannot even survive there in the first place. So option A is not part of it. B, the inside of the lift is airtight. How will it be airtight? You can never. Option B is not part of it. C, there is no reaction from the floor to the lift. Very likely. Let's look at option D first. There is no gravitational pull on the man in the lift. Never. D cannot be it. B cannot be it. A cannot be it. Option C is the best. He said, there is no reaction from the floor to the lift. Of course, that is the reason why the man does not feel any weight, because there is nothing from the ground reacting on him. All right, we've looked at this question before. Look at the final, the theory final. It says a body accelerates uniformly from rest for t time seconds. The kinetic energy of the body is directly proportional to the displacement, is directly proportional to the square of the instantaneous velocity, is directly proportional to t square, depends on the value of the acceleration. Which of the option is correct? The best option here is 1, 2, 3, 4, because all are part of the kinetic energy. Please, this lesson, you need to combine it with the lessons on projectile. That will be complete. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that makes learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the video to people that will benefit from it. Bye.